Hello viewers, welcome again to my channel, Second Math Hub, the solution to your math problems. This is lesson 6 on indices. And in this lesson we are still simplifying indical expressions. So for question number 3, I'm reading the preamble. Without using calculators, we are to evaluate the following. Now starting with the A. So with the A we have a fractional index with the numerator being 49 exponent 2 on 3 dividing 49 exponent 1 on 6. Also for the denominator we have 1 on 7 exponent negative 7 on 6 multiplying 1 on 7 exponent 1 on 6. So the first thing we are going to do is that we are going to write both the numerator and the denominator as a single index. So how do we do that? Now starting with the numerator, we see that the bases are the same and then they are divided. And then from the second law, it says that anytime the bases are the same and then they are divided, what do? You write one of the bases. In this case, we write 49. And what do we do to the index? We subtract the index. So the first index here is 2 on 3 minus the second index, 1 on 6. And also for the denominator, we see that the bases are the same, but this time they are multiplying. And anytime the bases are the same and they are multiplying, what do? We write one of the bases. So 1 out of 7. And what do we do to the index? We add the index. So the first index minus 7 on 6 plus the second index 1 on 6. Now the next thing is that we are going to simplify the index or the exponents. So now 2 on 3 minus 1 on 6. So the LCM here is 6. 3 goes into 6, 2 multiplying 2, 4. 6 goes into 6, 1 multiplying 1, that is 1. So we have 3 on 6. And this can be simplified as 1 on 2. So for the numerator, we are having 49 exponent 1 on 2. Now also for the denominator, minus 7 on 6 plus 1 on 6. So these are like fractions. So for like fractions, we write one of the denominators and we simplify the numerator. So minus 7 plus 1, that is minus 6, and this is simplified as negative 1. Okay, so we have 1 on 7. Okay, let me put them in bracket. Exponent minus 1. So now let me get a space here. So now, let's also simplify the numerator and the denominator. So how do we do that? We see that we can write 49 and then 1 on 7 to have the same base in indices. So for 49, it could be written as 7 exponent 2. And this will multiply the already existing index divided by, so how do you write 1 out of 7 in index form? So this is written as 7 exponent negative 1. And this will also multiply negative 1. So let me repeat this. We have 7 exponent 2 multiplying 1 on 2. 7 exponent minus 1 multiplying minus 1. So now for the numerator, see that the 2 will cancel out. And then you end up getting 7 for the numerator. And also for the denominator, minus 1 multiplying minus 1. So that is positive 1. So we also end up getting 7. And what is 7 on 7? 7 on 7 is 1. So that's the answer. Let's also look at the B. With question 3b, we are to evaluate the fifth root of 2 exponent 10 multiplying 7 exponent 5 multiplying 3 exponent 15, leaving your answer as a product of prime numbers. Take note, we are to leave our answer as a product of prime numbers. So how do we do that? The first thing we do is that we need to do away with the fifth roots. So how do we do that? Now recall from the fractional index property. That is, we said that the square root of any number is the number exponent half. The cube root of a number is the number exponent 1/3. The fourth root of a number is the number exponent 1/4. So the fifth root of a number will be the number exponent 1/5. So it means that we are going to write down this number, which is 2 exponent 10 multiplying 7 exponent 5 multiplying 3 exponent 15, and then we change the fifth root to an index of 1/5. Now what is the next step? The next step is that we are going to use the index to expand. We are going to use the index to expand. So how do we do that? So we have the first number 2 exponent 10 multiplying this index 1/5. Then the second number 7 exponent 5 multiplying the same index, and then lastly the third number 3 exponent 15 multiplying 1/5. So let me repeat this. So consider the index, some of the index can cancel out. So let's simplify. 5 goes here 1, 5 goes here 2, 5 goes here 1, 5 goes here 1, 5 goes here 1, 5 goes here 3. So what is left? We have 2 exponent 2 multiplying 7 multiplying 3 exponent 3. Remember that we have to leave our answer as a product of prime numbers, and that is what we have done. So that is the final answer. So this brings us to the end of lesson 6. Please like, comment and share the video. See you next time.